To make sure we are all on the same page, we are going to start off with some OSHA definitions. Center of gravity is the point on an object at which all of the object's weight is concentrated. For symmetrical loads, the center of gravity is at the middle of the load. Counterweight is the weight that is built into the truck's basic structure and is used to offset the load's weight and to maximize the vehicle's resistance to tipping over. Lateral stability is a truck's resistance to overturning sideways. Line of action is an imaginary vertical line through an object's center of gravity. Load center is the horizontal distance from the load's edge or the forks or other attachments' vertical face to the line of action through the load's center of gravity. Longitudinal stability is the truck's resistance to overturning forward or rearward. Track is the distance between the wheels on the same axle of the truck. Wheelbase is the distance between the center line of the vehicle's front and rear wheels. A powered industrial truck's stability is influenced by several factors, including, but not limited to, its wheelbase, track, height, and the location of its counterweight. The load center influences stability as well. An easy way to explain longitudinal stability is to use the seesaw or teeter-totter example. Imagine your powered industrial truck as a teeter-totter with wheels. The powered industrial truck's front axle serves as the center of the teeter-totter. The counterweight is the weight on one end and the load is the weight on the other end. The purpose of the powered industrial truck's counterweight is to keep the teeter from tottering. The weight that goes on the other end, the load, is limited by the powered industrial truck's capacity chart so that all four wheels stay on the ground. Since you steer with the rear axle, this is especially important. Other factors that influence both longitudinal and lateral stability are the location of the load center on the forks, the height of the load, and the degree and direction of the lean of the truck when operated on a surface that is not level. The stability triangle is another way of communicating the concept of stability. Imagine that the two front wheels of the powered industrial truck make up 2 points of the triangle. Then imagine the center of the rear axle makes the third point of the triangle. The goal is to keep the powered industrial truck's center of gravity within this triangle. The farther that the load center is located from the rear of the forks, the closer the center of gravity is to crossing the line between the wheels of the front axle. The higher you elevate a load from the working surface, the closer the center of gravity is to that same line. If driving on a working surface that is not level, the center of gravity moves toward the low end of the slope. This is why grades in excess of 10% must be traveled with the load upgrade. Can you think of anything else that might cause the center of gravity to shift? How about the influence of dynamic forces created when a powered industrial truck moves, stops, or turns? How about when a load is raised or lowered? Correct. All of these affect your powered industrial truck's center of gravity and therefore affect its stability. By now you realize that your powered industrial truck is not exactly a Sherman tank, and it's not as simple as it may first appear. Your powered industrial truck is limited by its capacity, stability, and by the speed at which it can be operated. The operator's manual and the client representative at your worksite will be able to give you more specific information regarding operating limitations. There are certain OSHA requirements for all powered industrial truck operators. These requirements have been set in place by OSHA in order to keep you and your coworkers safe. There are many requirements, so we will break them down into parts to make it easier to understand and remember.